actually learn better from them than someone who's a master at it. So if I go to like a mechanic shop and I ask them to teach me something about like how to work on my car, it'll be harder for me to learn from them than if I learn with somebody else who's learning with me. That's the reason we work in groups in here. So like that is one of the key critical things. So let's go look at those homeworks, and if we have questions, let's talk about them. Because 219 isn't super critical that we get to it like today. And if you're good on the homework, you can go ahead and start 219 if you want. You can grab a book because this is not going to be up here. But 217, 218. So let's look at those answers. We did this one together, at least I think we started it. The associative property dealt with the parentheses. The commutative property moves numbers around. We commute, we move. Brenda.
This isn't about the homework, but I noticed this today when I was doing something in Go Cultures. If you just write the parentheses and the comma when you're writing something for a graph, it does look like a bud. You can see in like the parentheses, you can see the curve. It's weird.
Yeah, you're right.
Right down in paper.
It is weird.
Yeah.
Here, I'll even do you one better. Since you're saying, yeah, some of this is getting challenging, and it's going to get challenging, right? We're not here to do easy math. That would be boring. Here, I'll show you my homework. Here. If you don't have 217 done yet, here you go. If you did it all last year, sweet, your teacher taught you really well, and we will get to new stuff soon enough. Woo! All right, so then, this is what I was talking about with graph paper. If I was you, I would have grabbed a piece of graph paper to do my work on. C, I gotta like scooch this. C, guys, is totally different than what this pattern up here is. Because this pattern up here is like the figure number. Well, can anyone tell me how, like if I wanted to write this out as like a function for how many blocks or squares will be in our... Amelia, you want to go ahead and tell us?
N plus 1 would no
Yeah, it would.
Yeah, squares.
Our shape is a square. How is it a square? We'll take this number, add 1, and that's your square. So figure 4 is a 5 by 5. This should be a 5. My brain tricked me because it's a 6 by 6, and I wrote 6 by accident. But it's figure 5. So if we wanted to, we could say n plus 1 squared describes this. But down here, what we're doing is adding the same amount each time. So actually, if we wanted to write this one out, we would have to go back to figure 0 in a way, sort of, kind of. We'll talk about formalizing these together. This doesn't all need to make sense yet. I'm not testing you on this stuff yet. Jake?
Wouldn't the bottom one be proportional? That one right there where you're doing
This one close to proportional. It's linear, but not proportional, and I'll show you why, like right now. So if I wanted to say what I start at 1, even though that's figure 0. Here's why we say we start at 1. Because then I'm going to add the n for like nth figure, whatever, times, okay, we can write the 4 first since somebody shouted it out. I'm going to add 4, however many figures I have gone. So when n is 1, right, I add 4 once, and I get my 5. When n is 2, I add 4 twice. I get my 9. When n is 3. So, guys, if you... I need your eyes up here because I got people not listening, and I think they're the ones who made this mistake. If you say, add 4 to the previous, is that true? Yes. Sure, we're adding 4 to the previous. But could I use this, like cover up that, could I use saying add 4 to the previous to figure out the 100th term? No, because I don't know what the 99th term is. So we got to start getting better than this. Like, it's okay if this is still how we're thinking. If we add 4 every time, that's fine. That is what we do. But we got to start thinking about where would I start and then add 4s. All you really need to have here is we add 4 each time, and then you could figure out figure 8 in any way you want. But if I use my equation, I can just plug an 8 in here. What's 8 times 4? Plus 1 more? 33, so figure 8 would have 33 squares, or tiles, or whatever. All right, flipping to the back. Perimeter and area, and then they tell us what x would be and what y would be, so I wanted my answers written up here. So, guys, you don't have to write your answers right in the little spaces. You can put them elsewhere. You can use Post-its or graph paper. Like, if you can't fit it in, put it wherever you want. I don't care. But this would be 4y plus 2x plus 2 if y was 10. If x was 6, our perimeter would be 54. So A is perimeter, right? And if we walk around the shape and collect our perimeter, and this is why we're going over the homework. I figured there'd be some like questions on this. This is y, right? This is y. And this is y. But chill. Stop. No, it's not. Not yet. This would be y. But it's not because it's missing this much of it. This section is 2. So we would start by calling this y minus 2. We don't yet know that y is 10. Right? Don't read that part yet. And then this is x. I like to group my ones. So 1, 2, 3, 4. So there's 4 around this corner. And another x. This is how we end up with 1, 2, 3, 4 y's. 1, 2 x's. And 4 minus 2 gets me plus 2. Questions on this? Jake? Yeah, there's always multiple ways. As long as you get to Florida so we can go to Disney. My analogy of there's a lot of right ways to get to Florida. As long as we get to go to Disney, we're happy. I don't care how you drive to get to Florida as long as we meet there, right? You could even fly, I don't care. Go to Texas first, then come back to Florida, whatever. What I'm saying is, like, sometimes there are more difficult ways to solve the math, but you might still get to the same answer. It's okay. And then we'll work on finding the best ways, right? The most efficient way to get there. And our calculator check. Seriously, you need to do this. Check that you can use a calculator correctly, because if you don't get one of the answers in the answer list, your calculator's playing tricks on you. So I tried to make this super easy for you to check. A goes to 4, B goes to 1, blah, blah, blah. Or I can come over here and say, where's negative 16 go? It goes to B. I also drew the lines, but that's a little complicated. Brenda.
My calculator doesn't make negatives even when I put it in parentheses.
What kind of calculator do you have?
A scientific one.
Well, there's a lot of those. So this is when we should probably discuss the fact that minus and negative are 2 different things on your calculator. Most calculators have this. This is what we need to use for negative. If we try to use minus as the negative, it doesn't work. Remember, guys, I'm going to say this a lot this year. Your calculator's stupid. You got to be smarter than your calculator. You use your calculator to do the work you don't want to do, but you still have to think. We could also ignore negatives when I go to type it in and say, well, a negative times a negative times a negative will equal a negative. So when I go to type this in my calculator, forget the negatives. I'm just typing in 4 times 2.25 times 10. I already know the answer is going to be negative. We will practice these skills this year. 2 negatives make a positive. Any odd amount of negatives stay negative. Any other questions from 217? Get out 218 if you have it done. If you don't, it's totally fine. You can still get it out and look at it if you want. Where'd my 218 go? What the heck? Yo, the answers are up there. All right, so let's look at 76 together. Because I know some of us have done this, but some of us probably haven't yet. How do I get to 76? Hey, there it is. So guys, if this is our algebra math, anyone figure out what these two lines down the middle mean? Because we didn't formally talk about it yesterday, but if you read, it is told to you. Brenda? Yeah, that the two sides are equal. So especially if you don't have 218 done yet, get it out. We're going to do 76 together for you. What CPM is looking for you to do here is write out the value we have on the top and then write out the value we have on the bottom, putting an opposite symbol in front of it. Here's what I mean. Since on the tiles blue is positive, red is negative, I'm going to do that. So in the positive part of the mat, this, we have 2 and what? Negative 2x. But I'm still going to write it in blue because it's up on the top. In the negative section of the mat, by the way, I think I got the ghost to leave. So in the negative section, so we put a negative in front of it, or a minus. It has both names. You can even call it opposite. It has a lot of names. So the opposite of 1, 2, 3, 4 and a negative x. Well, that's weird. What's the opposite of a negative? Well, this is like when we drag it across. When we drag it across, what happens?
It's an X.
Flips. Turns positive, right? On the other side, so we're going to write equals. We've got 1, 2, oh, well, before we do this, we could probably make some zero pairs if we want, but I'm not going to. So I just write out everything we have. We have a 2. We have negative 3. And then in the bottom, so we have the opposite of a negative 2 and an x. Now we apply the opposite, like we're going to drag the tiles and flip them over. So, what's the opposite of positive 4? Negative 4. So this actually becomes, I don't have great space to write this, so just ignore that these words exist. We're going to drop all, no wait. Do I still have my positive 2? And I got to write all this down. So I got 2 still up top. My negative 2x still up top. Opposite of 4 is negative 4. Opposite of negative x. We're going to do more of these today using the mat thing on the board that you can see. Don't worry, we're going to practice a few of these. Equals, well, it is your homework, so it's up to you if you do it right now or not. But if I was you, I would copy this down if I hadn't done my homework yet. Opposite of, ooh, I forgot to draw this arrow. Opposite of negative x became the positive. I'm going to leave this for a minute because I think it would help us more if I pivot. Let's go to one that has less going on. I'm going to take a picture of this real quick. Get out a piece of graph paper. Actually, yeah, I did this right. Sorry, I made these last year. I keep forgetting. Get out 219's paper. Get out 219's paper. I put a bunch of these examples on here for you. 219, the homework paper. We're going to do 81 together. We're going to do this a little nicer because I'm going to take a screenshot and move some things around. .219 looks like this on the front. It's got these 5 mats. We're going to do all of these together right now. We're going to do all of these together. So what's that mean when I go to check your homework? All of these should be done, right? This should not be blank. So it will be a check minus if it's a blank. Here's your warning. Yeah, well, this part is really our classwork. Yeah, you can write it right here. You can write it off to the side. Now, if you don't have enough space, you get a Post-it note or a piece of graph paper or something. But I would probably at least start it right here because it's the exact same as what you're doing on your homework. And eventually what I'll test you on. All right, 81A is where we're starting. 81A. CC3. And then I'm going to go ahead and paste B up here so you guys can try it after we do A together. I want you and your group to exactly like what we just did, write down what we have on the left side and the right side, exactly how it looks right now. Exactly how it looks. On top of the left-hand side, we have X and 3. Any questions on how I have X and 3 on the left? Patrick? No. Max? Okay.
I'm extremely confused at what you're doing, and I don't have any idea.
Is your pencil in your hand? Are you writing what I'm writing? That's step 1.
Why are you writing it? Yeah, why?
So, what we're now doing, that's the question to ask. We have to stop playing with toys. I know, it sucks. At a certain point, we got to grow up, and we can't keep playing with Legos and things like that. Now, true confession, I still play with Legos. But we can't walk around with a bag of algebra tiles, right? You're not going to walk into work at your big boy job someday, or big girl job someday, and dump out a thing and be like, hold on, I'm doing math over here, right? So, the reason we're doing this, Max, you can't ask a question and then walk away. I know, but you just asked a question. That's poor timing. We'll catch you up later. It's okay. You really got to go. You really got to go. So these tiles that we could put on our desk, move around, group, 0, but like, we just can't do that forever. So we got to start writing what we have. Now, if you're at all behind on practice work, this is going to be a little challenging, and that's okay. We'll get you caught up. But we're saying we have left side and we have right side. And now, and if you missed this at the beginning of class, this is also, like Brenda told us, these 2 lines tell us that the left side and the right side are equal to each other. We're in a hunt to figure out what X is. And now that we know the left and right are equal, we probably can. I don't guarantee that we can, but we probably can. Does that help center us on what we're doing? Sorry, I kind of just picked up from yesterday, and I probably should have like actually started class again, since that was 25 hours ago. Thank you. So I was about to say, hang on to your question for a second, because I got a lot more to say. So also on the left side, in the opposite region, we have the opposite of a negative x, which we know if we drag it across here, what did we do yesterday? It flips. When we drag it across, it flips over. But we're not dragging it, we're just writing down what it looks like. The opposite of negative 1, and in the opposite side, positive x. You with me? It's okay if you're not. Tell me if you aren't. Let's talk about the right side and then see if you're with me. On the right side, we have the x value, and these are negative 2. Right? That's a negative, that's a negative. With me? So I wrote down a negative 2 and an x. It doesn't really matter what order I write them down in. In the opposite region, so the opposite of, I got negative 2x's and a positive x. Are we cool? Now I can start cleaning things up. First thing we want to do is drag our tiles up, like we did yesterday. Crap, but I can't move these. Okay, this isn't interactive, because I got to grow up and quit playing with my toys. So, and at some point you get told that, and it's heartbreaking, guys. Normally they say, like, go to college or get a job or something like that.
This is your job.
I know, it's a pretty good one, too. What's the opposite? Ooh, don't start this yet. This is what I'm trying to, like, teach you through, like, us doing. Drop these down. Drop down your x and your 3. Like, we're just writing another line. Guys, I'm gonna brainwash you. Math follows gravity. Math falls down. Every step we do. Anyone who taught you to do math left to right, that was a travesty. We should have never told you guys to do that. Math drops down. Things move down. So when we go to simplify what we have, we drop it down and we rewrite it. So now, the opposite of negative 1. Or imagine when we drug this across yesterday. What happened?
It became positive.
Flipped and became positive. Max, we should be writing this. Even if we're confused, it doesn't help if we don't write. Sorry, I'm talking to Max K. I know you just got back in here. So this is still 81A. Yes. No. I'm sorry, but right now, you need to follow my way. Because you just told me you're really confused, and we need to not do multiple ways. Once we get past confusion, then we can do multiple ways. Trust me, I have my reasoning. Been at this for 10 years. What's the opposite of a positive x? Negative. So when this drags across, it actually becomes a negative. Yeah, you can just write minus x, but minus gets some people in trouble. Like, minus in itself is just kind of tricky. Like, I'm not making jokes. Like, just, I like writing negative x. It's not right versus wrong. I'm not telling you have to follow that. Because now I can look at a positive x and a negative x that are now up in the same part. Right? If I drug this up here, it's up in the same part. What's a positive x and a negative x do? Those cancel, and my left side is actually going to clean up to just 4. So when our x's cancel, cleans up to 4. Huh? Sure, yeah. Notice, we don't erase. We drop down. Like, there should be no erasing in math, really, unless we do things wrong. And even then, sometimes it's just as good to cross stuff out and, like, still be able to see our mistake. Okay? So soon you'll be able to take whatever route you want, as long as you get to the right place. But right now, I'm asking that you just follow me, like guiding you on this journey. And also Post-its up here if anyone needs Post-its or anything. So tons of Post-its in that box. Bring down what's not going to change. Negative 2 is not going to change right yet. This positive x is not going to change right yet. What's the opposite of negative 2? Or sorry, negative 2x. So yeah, 2x. Sorry, I forgot to say the x there. What's the opposite of the positive x? Negative x. Or I could just write minus. So for my friends that really want me to write minus, I'll write minus there. Okay, if I have x plus 2x minus x. Oh yeah, 2x, because this would make 3x minus x takes me back to 2x. Just 2x, because, thank you for asking. If you don't know how we got here, thank you for asking.
I meant negative 2 plus negative 2x.
Yeah, so these cancel out at a positive and or a value and its opposite.
Wait, so wouldn't it be x equals 3?
No, x equals 2.
I don't care about the answer. I care about the process. You're probably going to hear me say that a lot this year. I never want you to stick up your hand and shout out an answer. That's like saying Will Smith dies at the end of the movie. No one wants to know that. How do I get x by itself? Undo what has been done to it. Should I undo the 2 first? Guys, give me your eyes up here. This is a trapdoor. Here's the honest truth. Like, for real. It doesn't matter what you do first. However, one way is much easier than the other. You could deal with this 2 first. Keep your eyes up here because it doesn't make sense if you don't watch. However, when I divide by 2 here, I have to also divide by 2 here and here. Like any other number that I have, everything has to divide by 2. And if this number isn't nice, things get real messy. The better way to go, not right versus wrong, but the better way to go is say, sure, this is doubled, but I'll deal with that later. Let's get rid of this negative 2. How do we get rid of a negative 2? Add 2 in.
You'd have to add 2 before 2.
So we do it on both sides. So now we discover 6 is equal to double the value of x. And now it is better to do the division. Not that we're not allowed, but it's just better to wait. All right, now that you're all probably potentially mad and frustrated and like, yeah, Mr. Hudson kept joking he's a bad teacher, but he really is a bad teacher.
Excuse this interruption. Could I please have Andrew Schwartz to the office? Andrew, please come to the office. Thank you.
Put your eyes on your paper on 82A. It's the next problem down. I know, but this one has the E tool that I can use, and we're almost out of class time. This is 82A, right? This is what we were doing yesterday. This is us playing with our Legos. So, what do we have? I don't know why people are making noises. What we have, I should really switch how I'm recording, a positive 2 and a positive x squared. Right, so down here, a positive 2, a positive x squared. The opposite of 2 negative x's, I guess negative 2x. Malachi?
Before, especially on the smaller questions, you think we could, instead of having to add it to negative 2x, we could just make it 2x? Because we already know that it's going to be.
Oh, so you're saying this is kind of silly, and what we would rather do is whoop, whoop, and that's easier?
Yeah.
Okay, so then what do I write then? X 2x plus 2. That's the exact same thing as what we just wrote. Do the right side. You could write down like the opposite of method that we did, or because now we can visualize it a bit easier, if we drag and flip, yeah, things become easier. I get it. It becomes easier, but everything isn't always easy in life. Most things kind of suck a lot. So I'm going to go ahead and jump off of this question because we don't have too much time left. Let's look at a really tricky one. If we have to write out exactly what is shown here, challenge, write out exactly what you see here. And it's on your paper. This is C. I mean, you don't have to write out each one individually.
Can we flip it?
Not yet.
Okay.
Not yet. Guys, why do you think I'm saying no to all those things? Well, so that when I say yes, you're a whole lot more happy about, like, sweet, I can do that math. I'm allowed now. When, like, most of the time kids are like, man, I don't want to do it. But now we realize how much more efficient it is to see what cancels out, what groups together. So if I write exactly what I have a positive 1. That doesn't look like a 1. 4 negatives and a negative x, or a minus x. And down here I have the opposite of 4 minus 1. Right, 4 and a negative 1. Okay, now if we start to actually make 0, yeah, that's what I was just getting in the debate of which order. So a negative x and a negative 2, which I could write as minus 2, but I don't really like to do that. It's just a me thing. You guys can write minus 2 if you want, but. And then what are these? Yeah, the opposite of 4, right? So the opposite of 4, or you could just write negative 4. But if I write it kind of how it looks, it's in the opposite side, opposite of 4. Okay, now, when we clean this up, those are 0. Those are 0. I think that's it. So guys, these making 0 is us doing 1 minus 4. What's 1 minus 4? Negative 3. And I still have that negative x. And we said these all become, well, what's this simplified down to? Negative 3. Guys, we're doing algebra now. Like, this is algebra. So my left side, we say we still have a negative 3, another negative 3, and a negative x. Notice I was saying minus 3 minus 3 minus x is kind of, wait, what? I started that by saying minus 3. You can't really ever start by saying minus 3. After this, we'd have to say negative 3. If I have a negative 3 and another negative 3, though, what do we really have? Ooh, careful, it's negative 6. Somebody fell on the trap door of thinking 2 negatives make a positive, which is true in multiplication. So we have negative 6 and we still have negative x equal to, or minus x. Yeah, you can say minus. So we said this is actually negative. So what do we get when we put them all together?
Negative x equals negative 6.
Be careful, negative x and negative 6, right? I like that a lot better.
When x equals 6, then no. Yeah, because they're both negative.
Let's go back and do what we just did visually, because y'all don't like me right now. And that's fine. You're not always supposed to like your teachers. So 0 pairs, gone. 0 pair, gone. No other 0 pairs. Drag and flip now, right? Drag and flip, drag and flip, drag and flip, drag and flip. Ooh. Drag and flip, drag and flip, drag and flip. So somebody just said do same thing on both sides, right? If I take away a negative x, take away a negative x.
Take away negative x. 0. Take away negative 0. No. Wait, it's 0. You can take away
Wait.
negative 6 from each side.
Y would equal anything. Wait, no.
X.
Would equal anything.
What do you mean?
Because you can't tell because there's an even amount. Because if you take each away, then you just be left with 1.
Guys, what if instead of taking the x's away, we take the 6 ones, or the 6 negatives away? So what Maddie's saying is, wait, so negative x equals negative. If a negative number equals the negative number, doesn't the positive number equal the positive number? And wait, if x equals x, what is x allowed to be? Anything. So this is one of the special situations where literally our answer becomes x equals, if I can't write, A-R-N. Meaning any real number. Yes, there are imaginary numbers, just like my imaginary friend Bob over here. Real numbers. We'll talk about imaginary numbers another time. Any real number. Now wait! I got another situation for you though. What if instead, really today is just us figuring these ideas out. I know what you're asking. If we need to continue 219 tomorrow, totally fine. If we need to push closure to Monday, totally fine. If I need to pump the brakes, totally fine. But hold on, I cannot take your question because I need to fit this in and I need you guys to get to your next class on time. What if you had a situation that ended up saying like x equals x plus 2? So this is like saying Aiden's age equals Aiden's age plus 2. What I could also do here is take an x away from both sides, right? And now I have 0 equals 2.
No, that means x equals nothing. No.
It does not mean x equals nothing. That's the trap door, actually.
Wouldn't it be on x?
This is what we call no solution. What I call this is a big fat lie. This can't be true. 0 cannot equal 2. That is impossible. Math tells us that is not true. This is not equal. This symbol, guys, you need to know this symbol. We'll keep practicing it. This means no solution. This means not, I can't do it. It essentially means I give up. I mean, it means there's nothing else to do. All right, we got to get you out of here. Have a great day. I promise we'll do more of this tomorrow. We'll practice as much as we need to.